Last week, similar polygons have congruent angles. You have to know that. What was special about their sides? It's a word. It's going to be on your test. Starts with P.
P? Parallel.
You had it.
Parallel.
Starts with a P-R. O. Proportional. Proportional. Okay. Proportional. And remember, proportional, Jordan, proportional meant fraction equal to fraction. So if we set up side 1 corresponding to side 2 and side 3 corresponding to side 4, we would set those up in a fraction and they would have to be equal. That's what proportional means. Okay. Questions on similarity from last week. We also learned last week, Jordan turned. No, I don't know why we're not turned in the first place. We also learned last week 2 similarity shortcuts. Does anyone remember one of them?
Thank you.
We had angle. So we just needed 2 angles of one triangle to be congruent to the other. And then we also had side, where we needed 3 sides proportional to the 3 other sides. We're going to add one more. Our last one comes in today. It's side, angle, side. And that's our last one that we have for similarity. We don't have like an ASA or anything because ASA kind of fits in with our AA because there's 2 angles. So we don't even need the side because we have a 2-angle theorem. Okay? So what I've done in this application, if it lets me click on it, maybe. Okay, what I have done is I have set this up so that 2 of the sides are proportional, meaning A prime, when there's an apostrophe in math, we call it prime. So this is A prime. You don't need to know that, just that's how this was made. A prime goes with A.
When you write prime down?
No, like you would just write the apostrophe. Like this means A prime. Like this is how you say the apostrophe is prime. Essentially, the prime notation is saying like we took this A and we changed it a little bit and we got A prime. That's kind of what that means. But for our purposes, what I want you to know is that A prime goes with A, B prime goes with B, and I created them, Jordan, you should not even be looking that direction. And I created them a certain way so that their ratios would be the same. Meaning, if I put A over A prime, I get the same thing as B over B prime. Those 2 sides are proportional. Let's look at our pink angle. What I've also done is that if this pink angle gets bigger, this angle right here is going to get bigger. They're going to match no matter what. So what I've set up for us is a side, angle, side situation. Okay? Let's see if it makes our triangles similar. First, we can make our angle bigger. And if I look, that angle's still the same length. And if we also look, they do some fancy stuff, but my sides are still proportional. Okay? Let's see if the triangles are similar. What if I gave you that? That with these proportions and with this pink angle, this length, this measure, what happens with my green angle? What's special about those?
It's congruent.
They're congruent. So by angle, I could say that these triangles are similar. But I didn't start with angle. I started with side, angle, side. So that's kind of our vision here, is we now have side, angle, side, where we need a congruent angle, and then the sides next to it that make that angle included, we need those to be proportional. So let's kind of summarize that in our notes. So what we noticed about the side length was that they were proportional. Yes. We slid that thing, it did the cool graphics, and they told us that B prime over B was equal to A prime over A. We didn't technically know about our other side. Let's call this side C. We didn't know about side C, but we didn't have to because we knew enough. Were our triangles similar?
Yes.
Yeah, we got those green angles. So they were similar by AA. Technically, once I revealed the green congruent angles. So, how many sides did we need to know were proportional? What did we know up here? How many? 2 sides. Okay, we needed 2 sides. And how many angles?
2. 1.
1, just the pink one. The green one came after, just the pink one. What was special about that angle in relation to the sides?
Same one.
It was in between those sides. We needed the included angle. We got to stop playing the drums. Included angle. If you remember, included means in between.
What's that say?
Included. So like, for example, this angle right here is included with this side and this side. It's the 2 sides that actually make that angle. That's how it's an included angle. If you're talking about the 2 sides, it's actually touching. So then we can make our conjecture. I'm not going to have us actually write it out, but what we just found was the side angle side similarity theorem. So, if one angle of one triangle is congruent to an angle of a second triangle. So, in our picture, if angle X, what's angle X congruent to? M, angle M. So that's our first piece. We have a congruent pair of angles.
Bless you.
And it says the lengths of the sides, including those angles, are proportional. What is one side for the blue triangle that would make this angle X included, meaning it's touching this angle? What's one side? XZ, okay. So we would need XZ. What's its corresponding side? MP. So we would need that fraction, XZ over MP, to be equal to, because proportional is fraction equals fraction. So to be equal to, what side would we need from blue to make this yellow angle included? XY. We would need the other side that angle is touching. So we would need XY, and what does it match with? MN. The key here is that the angle has to be included. It has to be set up just like this. Okay? Jordan. Oh, he might be gone. Okay. So if you have those 2 things, you have angle and you have an included angle in 2 sides.
Yep.
And remember, we can kind of trace that out by, I would ask you, like, what is this? And you would tell me a side, angle, side, okay? So therefore, our triangles are similar. Triangle XYZ, similar to MNP by side, angle, side. So all we need is 2 sides and the included angle. But it has to be the angle in between. Remember, we don't have an SSA situation when the angle's not in between. Because you flip it around, reverse it, spells some no good things. So only side, angle, side.
So automatically if you have that, it's 2 sides and angles.
No, that angle has to be in between. It has to be SAS. This does not count. This means nothing to us. This does count. Angle has to be in between. Okay? So let's do some examples. Again, on your test, there's going to be like 4 problems. That's like a bunch of pictures, and it says, are these triangles similar? You would say yes or no, tell me the theorem, and write the statement.
Do you know how many questions our test is?
17.
Oh.
I already said that. You might not have been in here. I think you're in the restroom. So give him some slack. Okay. This says determine if the triangles are similar. Again, great examples to put on your cheat sheet. Let's, step 1, figure out what we have. Does anyone see, actually, before I get to step 1, I'm going to orient these triangles so they match up nicely. I'm going to take this triangle on the left and I'm going to flip it upside down just so I can easily match it with GJK. I'm just going to redraw it. So here's really this triangle on the left. I'm just redrawing it and relabeling it. H, G, J. I put H and G with J and G because those were both the smallest side. Remember, small goes with small. Okay. I can also label this 18 and 24. I had to put it this way because 18 had to go with 24 because small goes with small. Okay. I just reorganized it so it's a little bit nicer. Now let's see what I have. Do I have a pair of congruent angles?
Yes.
Which two?
90 degrees. G and J.
Yeah, so I can say, and usually I would name it with 3 points, but for now, one is fine. Angle G is congruent to angle J. We have one congruent angle. Do I see any other angles? No. If I had another angle, I would use AA and be done.
Yeah.
But now I'm looking for sides. We have to see if our corresponding sides are proportional. Let's see our 18. What does 18 go with?
32. Or JK. No, I mean.
18 is the smallest length over here. What's the smallest length over here? 24. So 18 has to go with 24. Let's see what that fraction is when we reduce it. What can 18 and 24 both be divided by? Huh? Not 4. More than 2. 6. 6. 18 divided by 6 is 3. 24 divided by 6? 4. We get 3/4. Whew. So we are hoping that when we set up our other pair of sides, we get 3/4. The other side length that we know is GJ. What number does that go with?
32.
32. So 24 over 32. What can both of those numbers be divided by? 6. Not 6.
4. I mean 8.
In between 6 and 6, or after 6 and 7.
8.
8. Okay, 24 divided by 8 is 3. 32 divided by 8 is 4. So, were our corresponding sides proportional?
Yes.
Yeah. So let's trace out what we know. Again, the highlighted pieces are what I know to work. What's this? Side or angle?
Side.
Side.
Angle.
Angle.
Side.
Side. So yes, the triangles are similar by side, angle, side. And now we just need our similarity statement. We need triangle similar to triangle. On your test, I'll give you one triangle. So let's just say on your test it tells you HGJ. And you have to match for your second triangle. So what letter should come first? What goes with H? What'd you say? G. What goes with G on the left goes with what on the right?
J.
J. And then J goes with
K.
K. So G, J, K. Questions on that one? Again, we needed 2 sides and the angle in between. Okay, let's do another one. This one has you compare this small triangle right here, LMQ, and the bigger triangle, LNP. I'm just going to, for convenience, draw my big triangle off to the side and just relabel some things so I can line them up nicer. So here's my big triangle.
Okay.
That is LNP. Let's find out some things. How would I find the length of LN?
Minusing. No.
Here's LN on this side.
Adding both. 16.
Adding, yeah, segment addition postulate. What's 16 plus 40?
56.
56. So LN is 56. What would LP be if we add it the same way?
49.
49. Very good. Okay. So that's what we know. Let's start with sides, because I don't automatically see any congruent symbols for angles. So let's start with sides. Let's see if LN over LM, those are the pieces that correspond. Let's see what that fraction is. So 56 over 16. What can both of those numbers be divided by? This one's tricky.
4.
More than 4. 4 is really more.
5. No, 8.
8. What's 56 divided by 8?
Bottom one's 2.
The bottom one's 2. Okay, 16 divided by 8 is 2. 56 divided by 8? Oh, you got it.
5.
No, way more than 5. Not way more, but more than 5.
6 or 7.
Let's see. 7 times...
6, 7 or 7.
It is 7. It is 7. Just trying to lead you to the answer, and I couldn't. 7/2. We're hoping that when I set up my other side, I also get 7/2. Which triangle should go on top? My big one or my small one? Big one, because that's what I put on top over here. I just have to match it. So let's put the big number on top.
So it does not matter which one you put on top?
It doesn't matter unless you're finding the scale factor. Unless it specifically says the scale factor from A to B, it does not matter what goes on top. You just, as long as it matches every time you do it and you keep the same thing on top, you can pick it however you want. So we picked the big one to go on top, so 49. What does 49 go with?
14.
14, okay. What can both of those be divided by?
7.
7. 49 divided by 7 is 7. 14 divided by 7 is 2. So are the side lengths proportional?
Yes.
Yeah.
Imagine if it was 7/6.
Isaac, shush.
Sorry.
You should at least have a pencil in your hand, man. Okay. So our side lengths are proportional. I either need, here are my options. I need one of these three theorems. So I either need my third side or the angle in between. So if I look up here, can I find my third side ever? No, I don't know what NP or MO is, so I can't do that. What's the angle in between on my big triangle? Just what's the name of it? What letter?
Oh.
What's the angle for my big triangle in between my two highlighted sides? The angle. Pause. The angle. I just need one letter. Angle L. Whew. Angle L's between. What's between my included angle on my small triangle? What's its name? One letter. L. So I have angle L from my small triangle and angle L from my big triangle. Are those the same?
Yes.
How do we know?
Because.
Yeah, say it louder and prouder. Reflexive property, yes. This was a shared side or a shared angle situation. This was one of our hiddens, okay? I have angle L is congruent to angle L. And now if we trace it out, what's the pink part? Side or angle? The pink side. Angle for L, and then side for orange. So again, hiddens are totally possible. This one had a shared angle. But my answer here is yes, they are similar, bless you. By side, angle, side. Again, side comes from right there. Angles are right there. And then side is the orange. 210.
I have to do my eye thing.
Oh yeah, wait.
Oh, yeah, definitely make my glass.
Yeah, I grew up.
They asked you to redo it today?
Yeah.
Yeah.
What time?
She says just Monday.
Just like down to the nurse?
I don't know.
Probably not there because they're not in there anymore. Probably to the nurse. Let's finish the lesson. We're almost done. And then you'll go. Okay? Yeah, it's to the nurse. Okay, let's match up our triangles here. Let's start with the small one. LMO. L for the small goes with what for the big?
L.
L. Okay. M for the small goes with N. And then O goes with P. Isaac, don't throw things.
Yeah. No.
Questions on that one?
No.
Okay, this next one, we actually could have done this one we could have done this one after your section 1 of this chapter, but let's practice it. It says determine the value of x that makes the triangles similar. Well, what's going to make the triangles similar is if I have a fraction equal to a fraction. So let's set up our fractions. I always recommend finding our variable first because we need that in one of our fractions somewhere. I see our x here and here. Which one would probably be easier to work with? X minus 1. It's shorter, smaller. Let's work with the x minus 1. I'm just going to ignore the other x for now, unless I have to deal with it, but I'm going to ignore it for now. What number does x minus 1 go with? 18. Okay, so we put it over 18. Now for my other fraction, I had variables on this one. I'm going to try my hardest to only get numbers on the other side. Which side on the left has a number that it corresponds to on the right?
4 and 12.
4 and 12. That's how I get both my numbers. So let's set up 4 over 12. Again, just making sure that those top pieces come from the same triangle. And the bottom pieces come from the same triangle. Okay? What method do I use to solve this? Butterfly. So 18 times 4, that's 72. And then when we do 12 times x minus 1, we have to put that x minus 1 in parentheses. It's not 12x minus 1, it's 12 times x minus 1. Okay? What should I do on the right-hand side?
Distribute.
Distribute. Okay, so I get 72 is equal to 12x minus 12. Now what?
Plus 12.
Add 12, okay. I get 84 is equal to 12x. Divide by 12. X is 7. What's up? Zoom out or in? In? Like right there? Okay. Is that too much? That better? That's probably good. Okay, so that's one way we could have done it. Let's also set it up, just if we were feeling funky, let's set it up with the 3 times x plus 1. What does 3 times x plus 1 go with? 8. And that could have also been equal to the 4 over 12. Or we could have done like x minus 1 over 18 is equal to this. It just would have been more complicated. Okay? So my recommendation is to put your variable down first, fill in that fraction, and then on the other side pick only numbers if you can.
Would it be 12 over 4? Or doesn't that matter?
Oh, no, you're right. It would be 12 over 4. Thank you, Robbie. 12 over 4 if we were making our triangles match. Questions on that one? Same stuff we did in the past. Let's do one last one. It says you are building a shelter starting from the tree branch. Here's the tree branch. Can you construct the right end, meaning like this side, so that it is similar to the left end using the angle measures and lengths shown? All that this question is asking, it's worded weirdly, but all the question is asking is, are these two triangles similar? That's our job. I see, hopefully, a side angle side situation. Do we all kind of see that? I have two sides and the angle in between. Okay. It's like a tent. I don't know. Half a tent. Let's look at the left side first. The 6 and the 9. If I put 6 over 9, divide by 3, we get 2/3. So the pink, my ratio is 2 to 3. If I do the other side that I know, 10 and 15, leave Jordan alone. 10 and 15, what does that reduce to?
2 and 3.
2/3. So now I have two sides. I either need the third side or the included angle. Which one do I have? Angle or side? I've shown these two sides. What else do I have? Angle. I have 53 is equal to 53. So now if we kind of trace out what I have side, angle, side. So my answer here is yes, the triangles are similar. By side, angle, side. Yeah, this one was pretty short. And then if we wanted to match them, I could do FGH. That would be given to you on the test. But what does FGH match with? What goes with F? A. What goes with G? B. And then C. Okay? So again, we have a new shortcut for similarity, side, angle, side. This box down here goes through essentially the main parts of the past two sections. This needs to go on your cheat sheet with the pictures. Okay, this is just like the poster that I had last unit or the bottom of your notes page last unit, but I don't have a poster this unit because there's only 3, but this needs to go on your cheat sheet. Star it, highlight it, color coordinate it, I don't care, but it needs to go on there. Okay? Questions on that? Okay, you guys have the